Now we're going to talk about how to graph inverse variation functions. Remember, inverse variation has the form of y equals k over x, and the top is just, k is just a stand-in for a regular number. So first off, the graph of inverse variation has two parts. They're called branches. So basically, when you graph it, there's going to be one little part over here and one little part over there. And it can be reflected, but we'll talk about that. The x-axis is a horizontal asymptote, and the y-axis is a vertical asymptote. Now, asymptote is a new word, so let's underline that. Here's our definition. An asymptote is a line the graph approaches but never reaches. So basically, it's kind of like it's a guardrail. The graph just never gets to that point. All right, so we're going to draw the graph of y equals 6 over x, but to do that, first we're going to make a table of values. Quick note, x cannot be 0 because the graph is 6 over x, and we know that we can't have 0 in the denominator. It is undefined. So you can use your calculator to help you do this, or you can substitute negative 12 in for x and find out that 6 divided by negative 12 is negative 1/2 or negative 0.5. And then 6 divided by negative 6 is negative 1. And go ahead and pause this for a moment. Finish filling out this table. If you have your table in, it should look like this. And we're going to take these coordinates and graph them, plot those points, and then connect the dots to draw this graph. So for example, negative 12 and negative 0.5, that's left negative 12 and down negative 0.5, so about right there. And then the point negative 6, negative 1 is about right there. And we're going to keep going, negative 3, negative 2. Go ahead and graph these points and connect the dots. Pause the video for a moment to do that. Once you have it graphed, it should look like this. And mine isn't perfect. Yours doesn't have to be perfect either. Just the big idea that this graph has these two parts that are in quadrant 1 and quadrant 3. So let's talk about the domain and range. For this type of function, we've never had a function where it had two parts. The graph has two branches in this case. This time, there's a couple of things. We already noticed that x cannot be 0. And remember, our domain is the x values. Our domain tells us x values and what numbers x can be. In this case, x can be any number except for 0. So I'm going to say the domain is all real numbers except for 0. Or I can write that as x cannot equal 0. Now, similarly, for this graph, the y value never gets to 0. It doesn't touch 0. So I'm going to say the domain is all real numbers except for 0. So y can be all real numbers except for 0. And as we do these types of graphs, you'll see this over and over again. Basically, the domain and range are set up at the asymptotes. Now, let's go ahead and fill in this table and draw the graph. Remember, we're not looking for perfection, just a good attempt. So go ahead and pause this so you can fill in the table and then draw the graph. Okay, now we have our graph in our table. Just double take your table points there. And the graph, again, we're not looking for perfection, but in this case, the graph branches are in the second quadrant and in the fourth quadrant, quadrant 2 and quadrant 4. This one is reflected. So looking at the domain and range, though, still there's an asymptote here at the y-axis. That's the line x equals 0. The graph does not touch or cross x equals 0. So the domain is all real numbers except for 0. And the range, once again, the graph gets to y equals 0. It keeps getting closer and closer, but it doesn't cross that line right there. It doesn't cross the axis. So we're going to say the range is y does not equal 0. All real numbers except for 0. So those are the big ideas of these types of graphs. Let's get into a little bit of details here. Now, what you'll see is the graph of y equals 1 over x is the bold graph. So that's the one in quadrant 1 and quadrant 3. The graph of negative 1 over x is in quadrant 2 and quadrant 4 over here. And then it has these diagonal lines, the graph of y equals negative x and the graph of y equals x. Those are lines of symmetry. We're about to talk about those. So there are some key features for the graph of inverse variation. First off, for the parent function, the axes are asymptotes for the graphs. Axes is plural for axis. So y-axis and x-axis are asymptotes. And both graphs are symmetric with respect to those diagonal lines, the lines y equals x and y equals negative x. Now, the x and y axes are reflections of the two graphs. They're lines of reflection. So you can see the first branch for y equals 1 over x is right here. And then the first branch for y equals negative 1 over x is over here. They're mirror images of each other. All right. Now, we notice when k is positive, so the bold graph, our graph is in quadrants 1 and 3. When k is negative, that would be our lighter graph. Then the branches are in quadrants 2 and 3. Sorry, 2 and 4. Those are some more big ideas. Let's put this into practice and bring it all together. Now, we have some rules here for translations of inverse variations. Those rules can be a little bit tough to understand and figure out. So let's just write ourselves a guide. If you have some space at the top of this paper or at the bottom of this paper, let's just write a couple of rules here. I'm going to write some rules for the transformations. When we have y equals k over x plus something, the graph moves to the left. And when it's k over x minus something, the graph moves to the right from the original function. If it's k over x and then something is being added after the fraction, the graph moves up. If it's k over x and something being subtracted after the fraction, the graph moves down. And anytime we have the negative in front of that fraction, that's a reflection. So those are some of our big changes there. You need to go ahead and write that in your notes. You're going to use this guide quite a bit here. So pause and make sure you get that. All right, our picture here is just showing us some differences in y equals 4 over x. That's going to be our solid line. And y equals 4 over x minus 2. Remember, x minus something in the denominator means that the graph is going to move to the right. And if you notice, the regular undashed line is like this, and then the dashed line is over to the right. It is scooched over, or it's like a slide over. Now, we can also use an asymptotes to graph it. So remember I said your graph doesn't need to be perfect, but there are some big rules that we're looking for here. Now, first of all, let's look at how this graph changes from the parent function. X minus 2, if there's a minus something in the denominator, x minus something, that means the graph moves to the right. And in this case, this graph moves to the right 2 units. So I'm going to start where the asymptotes would be. And I'm going to go over to the right from the origin, go over to the right 1, 2 units. And let's draw an asymptote here. This is going to be our new guardrail, our new line that's an endpoint here. Now, the minus 3 that comes after the fraction means the graph moves down 3. So I'm going to draw an asymptote, start at the center and go down 1, 2, 3, and draw a line there. And these lines are my new asymptotes. Now, To graph it, I know that this graph should be in the first quadrant and the third quadrant. And I'm just drawing a basic idea of what that graph looks like. And there it is. Now, in this case, we say that the asymptotes are at x equals 2. So that's how far the graph moved. And also at y equals -3. So you can bring all this information together. Let's do just a couple more to put this thing together here. Go ahead and pause for a moment and answer, how does the graph change with this x plus 5? Does it move left, right, up, or down? So remember, x plus something in the denominator means the graph moves to the left. In this case, it's moving left 5 units. And this plus 2 after the fraction means that the graph is also moving up 2 units. So let's draw our asymptotes. Left 5, I'm going to start at the origin and go left 1, 2, 3, 4, 5. Draw my asymptote line here. The other one is up 2, so I start at the origin and go up 1, 2. Draw my lines here. And now I'm going to draw the graph, but it's not going to be in the first quadrant and the third quadrant because this graph has a negative in front. That means it's a reflection. It's not going to be in the top right. It's going to be in the top left and the bottom right. And that's how we use our asymptotes to graph. We have one last example here, or one last couple of examples. We're going to write an equation for translation of y equals 5 over x that has asymptotes at x equals -2 and y equals 3. So we're going to start with that parent graph they gave us, y equals 5 over x. And they said it has asymptotes at x equals -2. Now remember, we always change the sign of something that's being added or subtracted with x. So I'm going to write x plus 2 at the bottom here. And then it has another asymptote at y equals 3. I'm going to write plus 3 after the fraction. And that's how we write the function. Now, try to write the equation for this next problem. Double check your answer. Remember, left is going to be plus 4, and then up is plus 5. And that's it.